Welcome to the Deep Dive. We take your sources, unpack them, and find the most fascinating insights. Today, we're looking at the really extraordinary life and mind of John Archibald Wheeler. Get this. Age 4, he asks his mother, what happens when you get to the end of things? Just 4 years old.
Yeah, and that question, it genuinely seems to have set the trajectory for his whole life's work.
Hmm.
Wheeler lived from 1911 to 2008. A theoretical physicist who, well, he just wasn't afraid to ask the really big questions,
Cool.
always pushing the limits of what we thought we knew about
He
reality.
sounds like a legendary figure, not just for his own ideas, but for inspiring, well, a whole generation of physicists after him.
Oh, absolutely. He mentored some huge names,
Hmm.
people like Richard Feynman, Kip Thorne, Nobel laureates. And get this, he supervised 46 PhDs at Princeton alone.
Wow.
Yeah. And he wasn't just focused on the PhDs. He famously believed in teaching younger students too, freshmen, sophomore.
So a dedicated teacher, but also he was right there in the thick of major scientific shifts, right?
Yeah, definitely. He worked with Niels Bohr, for instance, explaining nuclear fission. That was absolutely pivotal. There's also the work on the hydrogen bomb at Los Alamos. For him, that was deeply personal. His brother Joe was killed in World War II, which really drove his conviction there.
Ah, I see.
And, the language we use in physics today, he shaped a lot of that. He popularized black hole, though, interestingly, an audience member apparently suggested the term to him at a talk in '67.
Oh, really?
Yeah. But he invented wormhole, those theoretical tunnels through space-time, and quantum foam.
Quantum foam, that paints a picture.
It describes space at the tiniest, most chaotic scales. And beyond coining terms, he's also credited with, well, basically reviving interest in general relativity after World War II. Kicked off what people now call its golden age.
Quite a legacy already. But then there are his more out there ideas.
Right. Perhaps his most radical and maybe most profound idea was it from bit.
It from bit. Okay, unpack that a bit. Is
Yeah.
he saying information is the basis of everything, like more fundamental than matter or energy?
Precisely. That's the core of it. He proposed that everything, physical particles, forces, space-time itself, it all ultimately derives its existence from answers to simple yes or no questions. From bits of information, basically. He called them equipment-evoked responses.
So we play a role in that. Our observations, our measurements, they actually shape reality. That feels huge.
That's exactly it. That's his participatory universe concept. His famous delayed choice experiment really gets at this. Basically, it showed that a measurement you make now seems to affect whether a particle, say a photon, behaved like a particle or a wave in the past.
Wait, so the present measurement changes the past history?
In a way, yeah. It suggests that the phenomenon isn't really a settled thing. It isn't real in that sense until you observe it. He stated very clearly, it is not a phenomenon until it is an observed phenomenon. And this idea, it was groundbreaking. It really laid groundwork for what became quantum information science.
Okay, but then this leads to a massive question, doesn't it? If reality depends on individual observations, on my questions and your questions, how do we end up experiencing the same universe? How does it all cohere?
That's the puzzle. And it's one that Wheeler himself really grappled with. He wondered how, quote, billions upon billions acts of observer participancy could possibly stitch together into the shared space-time we all seem to perceive.
Did he have an answer?
Not really a definitive one. He wrote about how difficult it was to reconcile these individual acts of observation with a collective reality. He famously summed up the dilemma, each of us a private universe, preposterous. Each of us see the same universe, also preposterous. It was a tension he acknowledged.
Wow, John Archibald Wheeler, truly a giant. His curiosity just seemed boundless, didn't it? Reshaping how we see everything from black holes to, well, reality itself.
Absolutely. His questions, even the unresolved ones, they just keep pushing us. He's rightly called a grandfather of quantum information science, a real pioneer.
And that final lingering question he wrestled with, how does a shared reality emerge from all those individual observations? Makes you wonder, doesn't it? What does that imply about our own place in the cosmos?